sessions, we are going to look at how to help children understand three-dimensional objects. So a good thing to do is to get them to count the number of faces, because objects like these are named by the number of faces. So let's have a look. We have got this object here. How many faces does it have? It's got 1, 2, 3, 4, 5, 6. Now sometimes kids might say it's got 1, 2, 3, 4, 5, 6, and that's perfectly fine. To watch how children count and ask them, is there a different way of counting it? Well, let's have a look at this one. This one has got 1, 2, 3, 4, 5. So it's called a pentahedron. Well, how many vertices does it have? 1, 2, 3, 4, 5, 6. What about edges? Edges where two sides meet. So we've got 3 on top, 3 below, that's 6, 7, 8, 9. What shapes made up the faces? We've got 1, 2 triangles, and 3 squares. Now let's have a look at this one. How many faces does it have? 1, 2, 3, 4, and 5. So this is called a pentahedron. Oh, hang on a minute. This and this two, they don't look the same, but they are both called pentahedron because it's got 5 faces. So here we have children start learning to understand that we name objects by their faces, even though they may not look the same. The other thing you may notice that some objects has got different names. So for example, like this one, kids will have no problem saying that it is a pyramid. And it is a pyramid, but it is also a pentahedron. What about this one? This one is a triangular base prisms. So you start getting children to understand the name in relations to the objects and in relations to the features of the shapes. How else can we help children extend their understanding of three-dimensional solid? One of the things to do is to get children to construct net. So for example, I have got, this is what we call a geo shapes. I have got 4 rectangular geo shapes. I'm going to click this. If you notice, they have got a teeth on one side and indented the other side. You click that on this end, and if I click this on this end, if I then fold it together, I will make a square base or rectangular base pyramid. Now children can find the nets and trace it on this side. The way to extend the task further is to get children to investigate how many nets can they investigate and can they make in order to, when they fold it, they will make a prisms. So if I were to move this on this side, can I do that? Yes, I can. What about if I put it on this way? What you want children to do though is, rather than going straight away and doing it, they have to think about it, see how the shape will fold in their mind, whether they can do it or not, before they proceed into doing it and trying it out. So in this case, if I fold it here, I realize that I can't do it. The important question is to get children to ask themselves, why can't I do it? Well, this one overlap. What happened to this side? This side hasn't got another square to seal it. An eminent mathematician of the 18th centuries by the name Euler has done a lot of work about three-dimensional objects. And he discovered that there is a relationship between the faces, the edges, and the vertices. And he came out with these relationships. Euler's relationships look at if you take the number of edges from vertices and you add the number of faces, you always ended up with 2. So let's have a look at whether Euler's relationships work with the 3 examples we have above. The first one is a hexahedron. How many number of vertices? There is 8. How many number of edges? There is 12. How many numbers of faces? There is 6. So 8 take away 12, add 6, we get 2. Let's look at pentahedron. How many number of vertices? We've got 5. How many edges are there? So it's 8, so 5 take away 8. How many number of faces? We add the number of faces and the answer is 2.